The purpose of the tutorial is to demonstrate the ability to isolate documents that best support a research question using selected techniques in a single database. The index or database in exploration is called INSPEC. Think about the tutorial as showing you the process of separating the gems from the rocks. When a query search returns too many records, it crowds the documents that you actually need. The demonstrations in this tutorial will collectively declutter your return list. Remember that the demonstration is exclusive to INSPEC. Other so-called gems may be found in other bibliographic databases like the NASA Astrophysics Database System, General Science Abstracts, Scopus, and ICI Web of Knowledge. These indexes can be accessed at the University of Toronto's homepage. We are going to start with a research question. Suppose you want to research the gravitational effects of light propagating through a black hole. This is what the interface for INSPEC looks like. INSPEC is one of 5 databases maintained by Engineering Village. Make sure that INSPEC and only INSPEC is ticked off. For this research question, we are going to run a controlled search. In other words, we are going to browse by the subject terms created by the indexer. The advantage of using a controlled vocabulary is that all representations of a topic are subsumed by a single word. In an uncontrolled search, your search terms will find the topic expressed in those terms only, and not the same topic expressed in different terms. You might miss out on some very important information. So let's run a controlled search. Move the cursor to the Browser Index tab and select Control Terms. We are going to search for, and thereafter select gravitational lensing. Now we will input a second search term. We will repeat the process, but this time we will search and select black holes. Remember to select and will return records that contain both search terms, whereas OR will return records with either terms. We are now ready to search. The query returned 241 records. It's quite a lot of material to dig through. Let's have a closer look at some of the records. How about 9 and 10? Did you notice that they are not about physics or theoretically related? That's okay. We can separate records like these by refining our search. Just go to the top of the window and select Refine Search. A special feature of INSPEC is that it allows for the filtration of different aspects of material. Just go to the Limit by section, and in the second row, select Theoretical. And in the same section, but in the third field, select Physics. We are now ready to search. The refined search returned 182 records. That's almost 60 records less. Not bad, but we can do better. In the fast-paced world of physics, keeping up to date is important. Look at this record here. It was published in 2006, and although it's fairly recent, you might want to search articles published in 2007 and 2008. We can refine by year. Just go to the right tab, and under Year, click 2008 and 2007. Then at the bottom of the page, click Include. The fully refined search returned 19 articles. That seems fairly manageable and fairly relevant to me. We are now going to investigate a second research question. Suppose you want to research gravitational singularity and its relation to space-time curvature. In this section, we are going to run an uncontrolled search. That is, you and I, the users of the database, will select the search terms. You should run this kind of search when the topic you are looking for is not indexed, or when you cannot find its close substitute. We are now going to reapply some of the techniques learned in 1.1 and 1.2, that is, selecting theoretical and physics. Notice the auto-stemming function shown above the mouse point. Auto-stemming automatically includes other variations of the word. If we consider, for example, the search term singularity, auto-stemming will cause a search to include records containing singularities and singular. This function should be left on unless your research topic is super specific. In the search for field, we are going to type gravitational singularity. And we are going to search in the subject title abstract field. Because we also want to know the effect of gravitational singularity on space-time curvature, we're going to add curvature to the same search field. But in order to only filter relevant records, we will add the term near as indicated in the tip section. The tip section is useful in developing the syntax of your search. I strongly advise you to apply some of these tips to your own search. The process of adding near will eliminate those records in which the term curvature is not within a proximity to either singularity or gravitational. This is useful because often the abstract of a paper will contain the same search words but far apart, and thus not in relation to each other. So let's now actually apply near. Adding near curvature to the search field and then going back down and clicking search yields 258 records. Had we not added near, we would have seen 120 irrelevant records confounded in our results. 258 is still quite a lot to work through. So once again, let's refine the query by limiting the results to 2009 and 2008 records. There we have 10 quality records.